Creating these classes requires equipment and services that cost money. If you appreciate this education, please think about going to elithecomputerguy.com and offering a one-time or monthly recurring donation. Welcome back. So in today's video, I want to talk about SOA, or Service-Oriented Architecture. So this is a way of designing your IT infrastructure where you focus primarily on the services that are required and not really the servers themselves. So when we talk about client-server architecture, we talk about something like an Exchange server providing email services, or a routing and remote access server providing VPN servers. One of the issues as an administrator is not only are you responsible for the configurations and the connections in order to connect to those services, but you're also responsible for dealing with the operating system, dealing with patches, dealing with antivirus, dealing with all of those things. So basically, when you're looking at administering your infrastructure, not only do you have to deal with the services that are actually needed by your users, but you're worried about all of the underlying components that actually provide those services. So when we start looking at a service-oriented architecture, what becomes very interesting here is it's a different way of looking at your architecture. Basically, the idea being, what if the server or whatever is providing the service simply becomes a black box to you? You're no longer worried about the operating system updates. You're no longer worried about the antivirus or any of those other things required to maintain the server. All you're really worried about is the connection between the client applications or the users and the services that they are trying to get to. And so why this becomes very important is in the modern world, when we start looking at cloud computing infrastructure and we start looking at all the services that are available from cloud computing providers, if you start thinking about things more as a service versus as a server, you get to do some interesting things, again, with your infrastructure. So if you're simply thinking about something like a database service, like in the old days, so if you were going to have a MySQL database, so you're going to be running a website with a MySQL backend or something like that, in the old days, that MySQL database would be on a server, probably a Linux server, that would have something like MySQL installed. And so you as the administrator, you'd be responsible for the MySQL database, and you'd be responsible for the MySQL running on the Linux server, and you'd be responsible for the Linux operating system itself, and you'd be responsible for all the hardware that provides everything for you. And so that can be a little difficult. That requires a lot of time and energy. And so one of the things you can be thinking about is like, well, do I really want a MySQL server? Right? This sounds a little weird here, but do I really want a MySQL server? Or do I simply want some kind of database service? My software has to connect to a database. Do I really care whether or not if I own that particular server or how that particular server actually runs? And so some of the interesting things you can do with a service-oriented architecture is, if you build things out, you can start with your own MySQL server. So you can have a MySQL database and a MySQL server, and you can have all that up and running, and you're responsible for everything. And then you start thinking about it, and you're like, you know what? I don't really want to run my own MySQL server, because if the CPU fan fails or something like that, everything goes down. So then you can start thinking about, well, okay, I need a service that provides a MySQL database connection. And so then you can go to a company, I'll show you this in a little bit, such as DigitalOcean, and they actually have database as a services. So you can actually migrate your data to them, and they actually run MySQL in their cloud, so that you now get all of the MySQL database services that you need, but you're no longer having to run your server. But then again, if you're sitting there and you think about the service-oriented architecture, right? Is it even, okay, we don't really need the physical server. We don't really want to worry about the operating system. Here's an interesting question. Do you really actually care if it's even MySQL? Now you may be sitting there thinking like, well, wait a minute. Well, if I need a MySQL database in order to run my WordPress or whatever else, of course I need MySQL. Well, no, actually you really don't. You just need something compatible with MySQL. You need something that understands MySQL SQL statements, structured query language statements, and can do something with that. And so that's where you can go to something like AWS Aurora. So that becomes very interesting. So AWS Aurora doesn't actually run MySQL. So it's a database as a service that is compatible with MySQL, but it's not actually MySQL. And with that, you get some very interesting things that you can do. You can have databases all the way up to 64 terabytes in size, and you can do a lot of new interesting things with it, because basically what Amazon has done is they've said, okay, we know that we have clients that use software that requires MySQL as a backend. The problem is MySQL, as it is, has issues, just like everything does. And so they said, hey, what if we redesign the entire backend? What if we redesign how our database itself actually functions? But we allow applications that require MySQL to be able to communicate with that database in the standard way that MySQL is able to communicate. And so this is a way you are now getting the database service that is compatible with MySQL, but is not even actually MySQL anymore. And so this is where we get to with service-oriented architecture. Again, when you start looking at email services for your company, do you really want an Exchange server, right? So if you have an Exchange server with your company, that means you have the Exchange server software installed on your server, which means you have to deal with the Windows operating system on your server, plus you have to have the physical machine. And so when you start thinking about a service-oriented architecture versus a server, you start thinking, well, really, I just need email services. I don't really care if it's Exchange server. I don't really want to deal with Windows Server, to be frank with you. So what provider or what other way could I get the email services for my end users without being hyper-focused on what the actual product is, something like Exchange? And so this becomes important in the modern world as we go forward, is what we can do is if we start looking at things like services instead of the actual products and servers, then we no longer have to be married to these particular vendors, right? Because that's one of the big issues in the technology world is sometimes companies are doing great things. Sometimes vendors are doing amazing things. Everything they touch turns to gold. It's beautiful. The price point's good. The quality's good. Everything's great. But again, with all these companies, they'll keep doing that for like 5, 6 years. They'll be amazing. And then something happens. They get a new CEO. Something else stupid happens. And then they start putting out trash, right? They start putting out Windows Vista. Anyways, so the problem you run into, right, in the old client-server architecture is if you're dealing with Exchange server, right, if your email services are provided by an Exchange server, and so the way you think of email services as just an Exchange server, the problem is if Microsoft puts out a really crap product, you're most likely going to have to buy that new crap product. The reason being is because you're not thinking about email services, you're thinking about Exchange server. So one of the things you can start thinking about is like, well, if you start building your infrastructure more just off of the service, then if Microsoft does something stupid, then you can transition over to another provider that will then provide you the email services that you want. So that's one of the cool things now, where a lot of people don't realize how flexible things have become over the last decade or so. But the fact of the matter is that you can have a company that's using something like an Exchange server. They can go from the Exchange server, migrate over, if all they need is email services or calendar service and that type of thing. They can migrate over to Google Premier apps, so basically the business class apps. They can go there. They can be there for 5 or 6 or however many years. If that starts going to hell, they could go over to something like Office 365, because now they're no longer married to the one particular product. All you're looking at is I need a particular type of service. You start to see this with things such as storage. So storage becomes very important when you're building out cloud computing infrastructure. And so if you go to Amazon or if you go to Azure, even if you go to DigitalOcean now, basically storage has simply become a service, right? So for you as the IT administrator, what do you care about with storage, right? So you have to upload backup files, or you have to have data stored somewhere for your infrastructure up on the cloud. What do you really care about? You care about price point. You care about robustness and uptime, basically that you can get to your data when you need to get to your data. You're worried about whether your security policies and that type of stuff will work properly within whatever infrastructure. And you're worried about maybe some things like HIPAA or PCI compliance or that type of thing, right? Notice, when I talk about the things that you're worried about as an IT administrator, One of the things that you shouldn't be worried about is what operating system is running your storage services. Things you shouldn't be worried about is what specific hardware is running your storage services, right? Things you don't want to be worried about is, again, the maintenance and all the underlying stuff for your storage services. So if you're sitting there, and before, back in the old days, when we thought about like basically file sharing or file storage, you would have a file server. And so that file servers was most likely a Dell machine or an HP machine, and that most likely had a Windows server operating system on it. And then you would have your RAID, and then you would have everything else. And so that was a very particular product. Now, if you can start thinking about it, it's like, well, I don't really care if I have a Windows server. I don't really care if I have a Linux server. I don't really care if I have a Synology server. I just need storage that deals with these requirements. And then you can go to DigitalOcean, and then you can go to AWS, then you can go to Azure, then you can go to Synology, and then you can look at Windows Server, and then you can look at the new Linux offerings. And then if you're simply looking at it as a service that's being provided, you can then go figure out, which one of these options fits your needs at the moment, and then you can go with that option. And then as things go in the future, since you're not really married to that particular product, then again, 5 or 6 or 10 years from now, you can look and go, okay, well, this is what we built out before, but now, we think the services will be provided from this different place better. And so that's the important thing to be thinking about when you're thinking about the service-oriented architecture versus the client-server architecture. The client-server architecture, you're not only worried about the services being provided by the server, but you also had to deal with the software, and you also had to deal with the operating system, and you also had to deal with the hardware, and you had to deal with the antivirus and all of that kind of thing, right? All of that was your responsibility. When you're dealing with a service-oriented architecture, you're hyper-focused on the services themselves that are being provided, and then basically how you look at it is how those services provided are more of a black box. You're worried about the connection. You're worried about the connection between your users or your system and the services. You're not so focused on what the actual back end of those services are. And when you start looking at things that way, there's a lot of new cool options on the table. So I know as soon as I start talking about like black box services, I'm starting to make a lot of people scared. You're like, what? What do you mean I don't really know how the services are being offered to me? What do you mean it's a black box where I don't really know what's going on the other side? Oh, Eli, I don't really trust that. Well, the first thing that I'll say for anybody that starts screaming and hooting and hollering about black box services is the fact of the matter is you most likely don't really know what the hell's going on in your own infrastructure anyway. It's very interesting when you start talking about cloud computing infrastructure and people start getting really scared about cloud computing infrastructure. They have a big blind spot. They have a big blind spot for how much they literally don't know what's going on in their own server rooms. There's this idea that because you can see a physical machine, that somehow that is safer or more secure or more reliable or something else than a machine that you can't see. But the reality is, at the end of the day, is it's most likely your machines are far more vulnerable than the cloud services that are being provided to you. Again, really think about it. How robust is your update scheme? How robust is your preventive maintenance scheme? How robust is your auditing of your security policies and making sure all user accounts have been disabled or deleted once people have left? Are you really sure? Are you really sure there's no global admin accounts that are just kind of wandering through your system that people just happen to have forgotten about? Basically, if you're dealing with a legacy infrastructure, somebody created a global admin account a decade ago, and yeah, it's just kind of there, there for the hacking if somebody wants to be able to get an access to it. So I think that's one of the big things is a lot of people, when they think about black box services, they start being like, oh, I don't know about that. But the reality is when you look at your Windows server, so you have a Windows 2012 server or 2016 server, and you're looking at that server, the first question I really want you to ask yourself is, do you really know what's going on that server? You really know what's going on? No, you don't. You don't. You just want to think that you do. So with these black box services, again, if you start going with AWS for storage or Azure for databases or anything like that, I would argue you have about as much understanding of what's going on in their black boxes as you do on your actual server yourself. The other thing that you have to be thinking about too is that when you're dealing with these multi-billion-dollar companies, that they're hyper-focused on security, right? When Netflix runs off of AWS, when major corporations run off of Azure, if Azure has downtime or if Azure has a major security problem, literally they're huge, billion, $100 billion business can literally disappear in the blink of the eye if they have a major security vulnerability or if they have a major issue. Whereas, again, think about with your own infrastructure, with your Exchange server. Okay, you've got your email Exchange server. Are you really sure what will happen if the motherboard fails on it? Are you really confident everything has been updated on that Exchange server? Are you absolutely positive that nobody has root directory access to where the email store is contained on that Exchange server and that some ransomware can't possibly get in there and basically encrypt your root directory? Are you absolutely positive about that? So that's one of the things to be thinking about from first, because I know a lot of people, they're gonna be like, black boxes. I'm like, man, we don't know what's going on with our systems. Literally, we don't. Again, like with the NSA, our people, right? The NSA was literally getting their hands on Cisco equipment as it was being sent to distributors. They were then opening the Cisco equipment. They were then adding their own little spyware hardware to that Cisco equipment. They were then sealing everything up and letting it go on its way. So literally, even when you buy equipment directly from the vendor, you don't really know what's specifically going on in that equipment. With the Chinese intelligence agencies, at one time they were infecting 500 gig hard drives at the manufacturer. So they were actually putting viruses and spyware into hard drives at the manufacturer. That was then getting shipped out. The idea being is back then 501 terabyte hard drives were large hard drives. And so the idea was those were the hard drives most likely that were going to go into government institutions and large organizations. So that was a way to get viruses and spyware past whatever security procedures that they had. And so this is an important thing to be thinking about. Again, you had this idea like, the black box, I don't really know what's going on. You don't really know what's going on with anything. So that's the first thing to think about. The next thing to be thinking about with this whole black box idea is to even start building your own infrastructure based off of the idea of essentially having black boxes. Now what do I mean by that? So right now, when a lot of people build out client-server architecture, everything is essentially on the same plane, right? So you have your Active Directory server, and you have your file server, and you have your database server, and you have your email server, and you have all of those within the same subnet, within the same security groups. Again, client computers are able to access all of those different servers relatively easily, and this is why we get so many ransomware attacks, right? Is because if everything is more or less on the same subnet, everything is accessible, then if a piece of ransomware is able to compromise something such as an administrator account, it is then able to get into those servers and then do things such as basically encrypt an entire hard drive. And so one of the things you can be thinking about is, even if you don't start planning to use cloud services yet, think about building your own infrastructure based off of a service-oriented architecture, right? So think about it, right? So if you need something like database services, so let's say you have a web server and you have a database server, and they do whatever it is you need your company to do. Right now, the web server and the database server are most likely sitting on the same network. They're just as vulnerable to each other. There's a whole bunch of issues going on there. So one of the things you can start thinking about is like, well, what if we can start separating this? What if we put the database server behind a firewall? We have that firewall, so only the specific ports that are required for the database connection are open, right? So think about it this way. So now you have your database service, so a service-oriented architecture. So your service simply happens to be provided by this particular server. Then you put up the firewall, and then you say only these particular ports are open. And then you secure things. So then your web server has to then communicate to the MySQL server through the firewall. So if you have that firewall up, You don't have SSH open. You don't have the SMB or the FTP ports. You don't have any other ports open. Basically, the only way to get to that database server is through the firewall with the specified ports. That's a way that you can then start making your infrastructure more secure based off of a service-oriented architecture methodology. Then from there, once you have that divided off, once you've built everything out to communicate in this fashion, then at that point, if you do want to go up and you want to start using a web service such as like DigitalOcean for their MySQL database as a service, or something like AWS Aurora, then it becomes much easier just to be able to migrate and move the infrastructure because you've already started designing your infrastructure around these concepts. Again, the same thing is true with like your file server. So normally now, your file server and your Active Directory server, they're sitting on the same network. It's very easy to access one or the other. And so one of the things to be thinking about is like, okay, well, if we're going to have storage, if we start thinking about not a file server, but you start thinking about storage. So how would we deal with storage in a service-oriented architecture, even if it's within our own data center? And the same thing is true. It's like, okay, well, maybe I would build out a cluster this way. So I'd have a storage cluster using storage spaces and Microsoft or something like that. So I would build this out, and then again, I would put the firewall up, and this is how the permissions would operate, so on and so forth. And you start building your infrastructure based off of these services being provided, and not based off of just the server. One of the other things too, that this makes it a lot easier when you start doing things like planning for the future or thinking about budgeting, because one of the big problems when you look at IT infrastructure is if you look at everything as just your IT infrastructure, right? It's your Active Directory servers and your email servers and your database servers and all of that, and you're trying to figure out how much money you need for the rest of the year or how much money you're going to need next year. It can be very difficult to figure out where money should be allocated. Well, one of the things to consider is if you start doing a service-oriented architecture type methodology. So here is your database cluster. Here is your database services. Here are your file services. Here are your compute, your virtualization services. Here are your VPN services. Once you've separated all of those things out, it becomes much easier to do auditing and do reports and see how the services are actually being provided to your end users, how fast things are, how reliable things are. Are things up to the performance that they should be? And so that's one of the things you can look at is if everything's been divided out and you have your database services over here, then it's easier to say, okay, how are our database services doing? Okay, so this is our database, server. It's providing the database services for whatever servers need it. How do we feel just about the database? How do we feel about the database services? And that's when you can have people go, well, I'm a little nervous because we only have one database server, so that's a single point of failure. It does back up, but if that single thing fails, then it's going to take us a day to get it back up and running. And so if you're looking at it that way, and you're only looking at just the database services for your infrastructure, then you can start thinking about, okay, well, should we then make a database cluster? So we can put multiple database servers, so they can be a cluster. If one fails, it'll be okay because you have other machines. And then you can look at it, you can think about the money, you can think about the budget. And now that you're only looking at that, you can go, okay, well, we could create, a cluster of 5 of these machines. But if we create a cluster of 5 of these machines, and it's going to be $2,000 per server, so that's going to be $10,000 for an outlay to create that cluster. Or again, if all we're thinking about is services, or look at what our database services are actually doing. Maybe if we put them up to DigitalOcean or AWS Aurora, again, then we're going to be paying $50 a month for the service, but we're not going to have to put out that full outlay. That's one way to be thinking about it. Again, if you start thinking about storage services versus simply a Windows file server, you can sit there and you can say, okay, Microsoft, with storage spaces and how they deal with storage, that's very nice. But again, Synology has some pretty cool options out there. Or again, AWS, you can start looking at your infrastructure in an entirely different way when you start looking at it from a services type idea than from the server itself. And as you start sectioning off your infrastructure into their own little black boxes, it then becomes easier to manage. It becomes more secure because, again, you only have the specific firewalls and services open that need to be open. And it becomes easier for planning and budgeting in the future because instead of saying, oh, I need the money to upgrade the servers, you can say, we have a bottleneck in the storage. Storage is a bottleneck right now, therefore we need to improve storage. Databases are doing fine, the database service is doing fine, so we don't have to worry about that. So it makes it easier to start focusing on the things that you really need to focus on. So let's first look at the horrible way a lot of client-server architecture is currently built. So again, so you understand a little bit better why this is an awful thing and why you hear about so many security incidents in the real world. So nowadays, again, right, you'll have your building and you'll have your nice little server room. And a lot of times in your server room, you'll actually only have a couple of servers, right? And many times those servers will do numerous different things. So you'll have your Active Directory server, which will also be your file server, which will also be something called your routing and remote access server. That's your VPN server. It also sometimes be your email server, that you really should not run Exchange on an Active Directory server. And basically, you'll have all of these different services provided by one or two different servers. Those will be on a subnet, those will be on a network, and basically all of the client computers within that building, within that facility, on that LAN, will be able to communicate with those servers to get the access to the services that they need. So they need Active Directory services, they need file servers, VPN, email, whatever else, they're able to connect. Now, the problem with this is that every service that is provided by a server not only has a service that you're given, again, Active Directory or email or file or whatever else, but it also has vulnerabilities, right? File servers have specific vulnerabilities, right? You're able to actually load files onto a file server. That's the entire freaking point of a file server. But that on its own is a vulnerability. If somebody can get some kind of nefarious file onto your file server, and who knows, maybe they can trigger an event to happen. Like when an antivirus scan happens, maybe they can find a vulnerability in your antivirus software. So when the antivirus scans that particular file, then that file is able to gain access to your antivirus software, and then it's able to compromise the server. Well, the issue is again, if everything is running on the same box, then you start adding up vulnerabilities. So you have a file server vulnerability, an email server vulnerability, a VPN vulnerability, an Active Directory vulnerability, just a Microsoft vulnerability. Maybe your Dell, you've got a Dell system and it has some kind of, SNMP agent or something like that on there. And so that's a vulnerability. You got another vulnerability, right? And so basically, if you have one server providing all of these services, you then start racking up all of these vulnerabilities. And so somebody might be able to compromise your files, your file server component. And once they've compromised a file server component, they're then able to gain access to the email services. And then once they've gained access to the email services, maybe they can get into the Active Directory services, and then everything goes to hell. Again, the big problem here too is if you're thinking normally, you've got the client machines, and so these client systems, or let's say Windows client systems, and so you try to lock them down. But what happens if a hacker comes in and he just attaches, or she just attaches their little box to the network? And again, since everything is on the same network, since all of the services are provided by the same servers, if this person just puts a little Raspberry Pi or an Intel nuke onto the network, it can start trying to find some vulnerability in something. And as soon as it's able to compromise one system, it then has a foothold and can start trying to attack everything else. And so this is the nasty old way of doing client-server architecture. That's just bad. You don't like that. So then you have the new kind of way of doing client-server architecture. When we start talking about virtualization, one of the things you start talking about with virtualization is you start building it so that each server only provides one service, right? So instead of having one physical machine, and that will provide Active Directory and email and VPN and all of that, what you do is you start creating instances of machines in order to do one specific thing. So you have an instance of an Active Directory server. So this instance, this server, only does Active Directory services. So it only provides Active Directory services, and so it only has Active Directory vulnerabilities. And then you have an instance of a file server, and all that does is provide, services for files. Then you have your routing and remote access server, your VPN server, and all that does is VPN access, right? And so basically, this is the new way of thinking about doing client server architecture, where since you can start doing virtualization and hardware has become less expensive, then basically you have a single machine that is providing any particular service. But the issue that you're going to be running into is basically all of the servers are still more or less running on the exact same network, right? So again, you've got all your client computers out here, and instead now, if I need an Active Directory service, I go to the switch, it sends me to the Active Directory server. I then need to share a file, it then sends me to file server. I then need to do VPN services, it sends me to the VPN server. So obviously, this is a lot better, but some of the problems you run into is everything is still more or less on the exact same subnet. So if somebody can compromise a server, somebody can compromise a client computer, they're able to try to hack every other system here. And the other issue that you're dealing with this is, again, a lot of this is Microsoft, right? So you got a Microsoft Active Directory server and a Microsoft VPN server, a Microsoft file server, the whole 9 yards, right? So you're still dealing with full-fledged servers that are providing the services. And so one of the questions is, what if Microsoft isn't the best provider of storage solutions? What if Microsoft isn't the best provider for VPN solutions, things like that? So that's where you start thinking about the whole service-oriented architecture. And when you start thinking about the service-oriented architecture, basically then you start to have the bubbles. And so with the bubbles, basically, let's say you have an Active Directory. So you have your Active Directory cluster. So this would be your security services, and those will probably be Microsoft. If you're dealing with the legacy systems, they'll be Microsoft. And so here, basically what you do is you set up your Active Directory domain controllers, and they're able to communicate. And what you do is you can put some kind of firewall or you put some kind of routing scheme in place so they're in their own little bubble. They're able to provide the Active Directory services. On the other hand, then you have, let's say, your web servers. So then you have your web servers. These provide your internal websites or possibly your external websites, those types of things. And there, you can start thinking about, what is the most appropriate way of delivering websites. Maybe when you start to begin with, again, it's running things like Apache web servers. Well, one of the things that you can do is if you have client computers, right? You have client computers and they need to access the websites. Really, the only way that they need to access those websites is through port 80, right? So HTTP is port 80. So what you can do is you can set up a firewall. Basically, you set up a firewall and you only allow port 80 traffic to come through to these web servers. So that means SSH is shut off. It means any other, basically, networking protocol won't be able to work. And so that's able to secure those web servers better. Then again, like I say, you've got your database servers. So let's say you're running MySQL. Again, and what you'll notice here is you have the web servers right here, and then the MySQL servers, your database servers, are actually separated from your web servers. So you look at whatever ports MySQL requires, and so your web servers then start accessing your MySQL servers, again, through a firewall. You have the ports set up, so only the ports that are specifically required in order to allow MySQL traffic to go through will go through. And so the interesting thing, as you start looking at these kind of bubbles, right, one of the things here is that the end users have no access to your MySQL database servers, right? In order for the end users to get something out of MySQL, they have to go to the web servers. The web servers then ask for information from the MySQL servers through the network that you've configured. And so there's no direct path for your client systems to be able to access those MySQL servers. And so therefore, your MySQL, your database servers become a hell of a lot more secure. You're not worried so much about ransomware being able to get into your database servers and being able to encrypt your root directories, because none of the client systems have network access to the MySQL servers. If somebody is able to compromise an Active Directory server, Active Directory servers don't have access to your MySQL servers, right? Because they have been segmented. segmented off. Well, the cool part about this then, again, as you start thinking about a service-oriented architecture, is you start going, okay, well, I got my Active Directory bubble. So if I've got my Active Directory bubble, and again, I'm dealing with Microsoft, so I'm going to have my Active Directory, services. They are going to be local, most likely, for the next 10 or 20 years. That's just how it is. Okay, so my Active Directory services, those are going to be run locally. I'm going to have a little Active Directory cluster, and it's going to be behind its own little firewall. And then you start looking at things like web servers. So then you've got your little web servers. Again, you have a little firewall in front of that. Only port 80 is allowed to go through. And you start looking at your web servers, and you start thinking, well, we might be able to put these online, but for whatever reason, we get better performance, right? We've got these Xeons we already own. Again, a big reason that people do things in the real world is that they already own the equipment. We already own these Xeon servers with 32 gigs of RAM, and actually they run websites really well. So we're gonna, if we're looking at this from a service standpoint, an SOA standpoint, okay, we're just gonna keep our little Apache servers here because that works out really well. But then you start looking at, let's say, your MySQL databases, right? So when you start looking at MySQL databases as simply a service, not a particular server, you might be sitting there going, I'm worried about this. The MySQL databases, they've been growing significantly. We've gotten more users, whatever. They're getting the crap hammered out of them. I'm a little nervous about the MySQL databases. I'm worried that we're going to make sure that we're maintaining them properly. I'm worried about the backup solution. I'm worried about all of that. So currently, the web servers are able to connect to our local MySQL database servers, but I just don't like the idea that we are running this. I don't feel confident. So one of the things you can think about then is when you've got the cloud, right? Again, you've got DigitalOcean. So DigitalOcean offers a database as a service. So then you can think, well, why don't we migrate the MySQL databases up to the DigitalOcean database as a service? And then all we have to do, because we've already designed our infrastructure to be this kind of component service-based thing, then all we do is we migrate the data up to DigitalOcean. We configure everything how it's supposed to be. And then now we just point our web servers to DigitalOcean instead of our local cluster. And so then we're able to turn that off, and now we're dealing with DigitalOcean. And then again, like when you start looking at it from the service-oriented way, everything becomes its own component, and then as your requirements change, then you can start moving things around again. So let's say you have the web servers now, and they're communicating up to the DigitalOcean servers, and then after a while, you're like, these servers that we have, they've gotten old. Again, I'm worried about security and all that. So let's go with AWS for our web servers. So we'll just migrate our web servers up to AWS for service. They will then connect to the DigitalOcean. We'll create the other connections, so Active Directory and all that works. And so things become more compartmentalized. And again, with all of this, if you set this up properly with security, you're starting to get more and more layers of security between all of these systems. So if somebody is able to compromise one part of your infrastructure, they're not going to be able to compromise all of your infrastructure. And so this is something just to be looking at. Again, we kind of diagram and write all of this out. And maybe this gives you a little bit better idea of what I'm talking about. So now that my world-class drawing has made everything so clear to you, let's go over to the computer, and I want to show you some of the offerings that are available for the MySQL database, right? So MySQL is a database that's been used for a long time now, and the cool part about it is that there are now more options for more vendors for not just MySQL services, but also MySQL compatible services. And so I just want to show you these MySQL options to kind of give you the idea of the different things that may be available for you. So again, like when you're going out there and you're looking for storage solutions, if you start thinking about storage and not simply a Microsoft file server, then you can start saying again, well, okay, maybe we do Azure storage, blob storage they have, or maybe do AWS storage, or maybe we do a Synology server, maybe we do a Linux server, right? You start thinking about the services being provided rather than the specific product itself. So let's go over and take a look at some of the MySQL options, and I think this will make it a little bit clearer for you. So the first thing to look at is just good old-fashioned MySQL. So if we come here, again, we go to MySQL.com. You can see the MySQL Database server that you can download and purchase, and they talk about all the cool options available for you. They've got the Enterprise Edition, they have the MySQL cluster, they have all kinds of cool things, right? So if you want to run MySQL locally, this is where you would go. You would download, you'd buy your maintenance contracts, you'd figure out how to build your clusters and all that type of thing. But what if you're sitting there and you're going, I want a reliable, good MySQL service, but I'm a little nervous. I don't want to worry about a CPU fan failing and taking down my MySQL services for my users. Well, then you can go over to something such as DigitalOcean. Actually has managed databases, database as a solution. Leave the complexity of database administration to us. We'll handle setting up, backing up, and updating so you can focus on building apps. And so if you go down here, you can look at the options that they provide. So this will be basically this is a MySQL database service for you, and it's scalable. They have the daily backups built in. They have automated failover. They have end-to-end security. So basically, you can go and you're able to rent a MySQL database server service that will provide all of the options that you want. Well, then one of the things you might be thinking about is like, well, I really like MySQL, right? We have all of these legacy applications that are using MySQL as a backend, but we're running into problems with MySQL itself, possibly the size of the databases or the sizes of the tables. There's a fundamental problem with the back end of MySQL where you're running into issues. And so that's where you can go over to something like Amazon Aurora. And so with Amazon Aurora, this is a compatible database. So their back end is not actually MySQL. Who the hell knows what's running on in the back end? I don't know. Maybe they got dead cats and they're swinging them around, and that's what makes the database services work. I don't know. But basically, they got MySQL and PostgreSQL compatible relational databases. And one of the interesting things here that I absolutely love is so Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that auto-scales to 64 terabytes of data per database instance. And so this is something to be thinking about. Again, let's say you built your software, you have some kind of legacy software that's been using the MySQL backend, and it's been using it for a decade, right? And so when that software was created, you had, I don't know, maybe you had 1,000 customers or something, right? So basically you had some kind of CRM solution, some kind of customer solution. Back 10 years ago, you had 1,000 customers and it worked really well. Well, it's been 10 years, you've been growing and growing and growing and growing. The software works great, that was created, but now you're starting to get worried because instead of having 1,000 customers, maybe you have 2 or 3 million customers. And those 2 or 3 million customers, they have all kinds of data associated with their accounts. And so then you start worrying about the size of the database itself. Like if the database gets too big under normal MySQL conditions, you may start running into problems, you might start running into corruption, that type of thing. And so if you go, oh, okay, what we can do is we are going to use a MySQL compatible database service from AWS, such as Aurora, then again, your software doesn't have to be modified. You can upload, you can import all of your data from the MySQL databases that you already have. Your MySQL connections within PHP or whatever software that you wrote, whatever coding language you wrote your software in, those will be able to communicate with a new database engine. And so basically all you have to do is you simply have to go in, do a couple of different pointers, do a couple of different passwords, do the import, and then basically everything is running just like it ran yesterday, but it's now running on a database infrastructure that can scale to a much larger size and be much more robust than you had previously. And so these are the things to be thinking about, again, as you start thinking about your infrastructure more as services versus servers. You can start thinking about these really interesting things that you can do. And so that's a brief overview of a service-oriented architecture and why it matters to you with real IT infrastructure. Now, to be clear, again, whenever I talk about these architectures, whether I'm talking about client-server or service-oriented or even serverless architectures, these are more ideas. They are methodologies about how you're going to be building out your infrastructure. They're not hard and fast rules. They're not hard and fast rules. Don't worry, for anybody out there that likes patching operating systems, server operating systems, don't worry. You're still going to be patching server operating systems for a long time to come. But this is more of the concept of how you're going to be building out your infrastructure, not just so it runs well today, but so that it's easier to future-proof your infrastructure and move things into the future. Again, if you just simply have one database server that's on kind of the same plane, the same network as everything else, when you start moving in the future, that might be a little bit difficult for migrating for what you'll be going to next. If you start designing things so they start getting sectioned off now. So again, even if you just have one single database server, you still have one single database server, but you take that database server, you put it behind a firewall, which is what you should do. You'd have a lot less ransomware attacks if you put your database servers behind firewalls and didn't allow SSH and a whole bunch of other things to be open. But anyways, you put your database server behind the firewall, you only open up the ports, and now that's acting simply as a service for the rest of your network. Again, you put your file servers, you put them into their own little bubble, again, behind a firewall with the correct security and all that kind of thing. And so now they're in their own little bubbles. This makes it a lot easier as you're trying to figure out what you need to invest in with your infrastructure. It's now easier to simply say, okay, the database isn't performing as well as we need it to, so we are going to focus on the database service, or the file servers are not performing how they need to, so we're simply going to focus on the file service. So the first thing that it does is it makes it a lot easier for you to kind of compartmentalize all these different services that are being provided. And then basically as you go into the future, when you start thinking about how to upgrade, again, like I say with MySQL databases, you sit there and you're like, well, okay, the MySQL database server, for whatever reason, it's not working, it's not functioning the way we need it to, so we need to upgrade. And then if you just start thinking about it as a service versus a server, right? If you're only thinking about the server, right? We've got a MySQL server. Well, then how you're going to look at improving that server is by upgrading the hardware on the server, buying a new fancy server, possibly creating a server cluster, right? If your focus is on the server, then you're going to simply be focused on, okay, how do I make that server better? Whereas if you're looking at it as basically a MySQL service, then you can sit there and go, well, I could buy $20,000 worth of hardware and create a MySQL cluster that I'm still responsible for. Again, if CPU fan fails or if it gets a virus, everything's going to go to hell. Or we're just looking as a service. Maybe if we put it up to, again, DigitalOcean, that would be a better way to go. Or again, like if you're getting a tremendous load on your MySQL database cluster as you have it, if you're simply looking at it from a server standpoint, then the idea might be, well, let's add a couple more servers and let's change your replication strategy, right? Because you're focused on just being a server. Where if you look at it and go, well, if it's a service, really, all this stuff that we're doing, if we put this up to AWS Aurora, we'll be able to dramatically increase the size of our databases, have a lot of improvements, and that will provide us a better return on investment. So those are the things to think about. And then finally, again, frickin' security. It makes me so mad. It makes me so mad every day I hear about these ransomware attacks. And again, having been an IT professional, being an IT professional, I guess, it's just, why does anything have root access to your database servers? Because basically, when you hear about these databases getting encrypted, a database is a file. A database is a file, just like a picture file or a video file or anything else. And so one of the questions really has to be, why did anything have the ability to have root access to your database store? Like at all. Like how was anything able to compromise that? If you had all of these things divided off in their own little services, again, yes, a client computer may get infected and it'll cause you some problems. Maybe, an Active Directory server can get infected and that'll cause you some problems. But if Active Directory is segmented off and your file servers are segmented off, and again, if your database servers are only connected to your web servers on the network and only connected to them with the particular ports that are required to be open. You have all this other, then you just, again, basic security. Basic security. So there you go. I hope this whole service-oriented architecture thing made a little bit of sense to you. I know my scribbles can get a little bit confusing, but theoretically, drawing on a whiteboard is supposed to, I don't know, do something in the brain to make all this stuff be a little bit understandable. So, as always, I enjoy doing this video and look forward to seeing you at the next one.